All right, section 1.1, we're going to start off just real basic. Speaking of basic operations with integers. Now, let's say this right away, and just something you want to keep in mind as we go through this section, and basically keep this, and this is something you keep in mind throughout the whole course, the whole semester. I will almost never deny you the use of a calculator. Like especially on quizzes and tests. I may never deny you that, but I'll say right now that I will almost never. So doing adding and subtracting and multiplying and dividing, just those very simple math problems, you can always just do it on your calculator, right? I will say this 100 times, that you should never risk doing something in your head if you're not really sure. It's okay to get a calculator out to do math problems, right? I mean, some people can do multiplication with certain, I'll say this. I have my limits, just like everyone has their limits of doing mental math, like the times tables. I can do 3 times 7 in my head with pretty much 100% confidence. But can I do 7 times 15? Can I do 12 times 13? Can I do 11 times 12? I have a limit, right? And so everyone has a different limit. Some people have trouble with like 8 times 6, But anyway, definitely it's better to be sure and grab a calculator if you're not sure. But with that being said, okay, so let's get back on track here. With that being said, it does help to understand the concepts of adding and subtracting and multiplying and dividing. Just because you can grab a calculator if you want doesn't mean it doesn't help you to understand what's going on with all these basic operations, and being able to do it naturally can be an advantage. Like the fact that I can do 7 times 9 in my head just like that, is an advantage in a lot of ways. So when you are adding and subtracting, here we go. It says here, when you are adding and subtracting negative numbers, think of money. What can that mean? Well, I mean, when you're subtracting something, think of it as losing money. If you have $50 and you're subtracting $20, then you're losing $20. You can even think of it as, adding and subtracting negatives. I guess to be more specific, if you had $50 and you were adding negative $20, that's the same as losing $20, all right? And just one more example, I guess. If you had $10 and you lost $30 in a way, I know that's weird to even say it like that, but if you had $10 and you lost $30, now you are like $20 in the hole. Like you owe somebody $20. Like you have negative $20, Like you lost your actual $10 and then another $20 that you were like in the negative, okay? So, some things to keep in mind before we even start doing problem after problem after problem. When you subtract something, you're, like as far as a number line goes, and this is a number line, if you're subtracting, you are heading to the left, if I want to do 9 minus 3, it's like I'm at 9 and I'm going 3 to the left. So subtracting something, you're moving to the left on a number line. And if you're adding something, you're moving to the right. Like if I'm doing 2 plus 5, I'm starting at 2 and I want to do 2 plus 5. I'm going to be doing like 1, 2, 3, 4, 5 to the right. And so, as far as a number line goes, 2 plus 5, gets me 7. All right? So again, not to be repetitive there too much, but if you're subtracting from a number, you're moving left from that number. And if you're adding to a number, you're moving to the right from that number. Like negative 7 plus 3, I would go to the right, 1, 2, 3, and I would be at negative 4. So negative 7 plus 3 is negative 4. But, on the contrary, negative 7 minus 3, I'd go to the left, 1, 2, 3. And negative 7 minus 3 is negative 10. So something else I want to make a big deal about, okay? Adding a negative is the same as subtracting. Let me say that again. Adding a negative number is the same as subtracting it. So adding a negative 4 is the same as just subtracting 4. All right? I know I'm doing this out of order, sorry, but 3 minus 4 is the exact same thing, okay? And so it'd be like on a number line, if you start at 3 and went 4 to the left, if you had 3 and like to bring dollars back in, if you had $3 and you're losing $4, well, you only have $3 to lose. So you'd end up actually in the negative and like being at negative 1. Okay? Which again, your calculator will back you up if you have even the slightest doubt of what these answers are. So anyway, let's now go back and do this sort of in order again. So 3 plus 4, well, this takes you back to, I don't even know, first grade? Kindergarten? I don't even know. But this is a kindergarten problem, basically. 3 plus 4, but, making it a little more advanced, when you kind of bring a number line into it and how you would do it on a number line, you're at 3, and if you want to add 4, you'd be going to the right. 1, 2, 3, 4. But, again, no surprise that it's just 7. Now, negative 3 plus 4, again, think of a number line, or think of, I don't know, if it helps, think of money, but if you're at negative 3 and you add 4 and you're going to the right, 1, 2, 3, 4, okay, that's 1. So negative 3 plus 4 is 1. And we did number 3 already. And again, number 4, adding a negative number is the same as just subtracting it. So it's just the same as to say negative 3 minus 4. And what is negative 3 minus 4? Again, you're at negative 3 and you're subtracting 4. Like you're getting even more negative, more to the left on the number line. So negative 3 and you're subtracting 4 even more, you're going to end up at negative 7. Okay? Negative 3, again, look at the number line. Negative 3, and now we're subtracting 4. 1, 2, 3, 4. You're at negative 7 now on the number line. Now, just more examples. I don't think there's going to be anything new here, but just more examples. So 9 plus 2, that would be 11. Negative 9 plus 2, if you were at negative 9, like think of where that is on the number line. Like we're in the negative at negative 9, and we're adding 2. we're heading to the right 2 places, and that's going to get us to negative 7. So negative 9 plus 2, and again, adding a negative 2 is the same as just subtracting 2, like that. And so what is 9 minus 2? Well, that's back to kind of kindergarten level. 9 minus 2 is 7, right? I mean, can you imagine if I made a mistake right now? Now, negative 9 plus a negative 2, that's the same as doing negative 9, just minus 2, right? And negative 9 minus 2, that gets us even more, like we're even going more left of negative 9, 2 places, and that's going to be negative 11. Subtracting. The only thing I'm going to point out real quick here is, well, maybe not yet. Maybe we'll actually do this one in order. So number 1, 3 minus 6. Well, like I've already said like 5 times, subtracting means you're moving to the left. So if you are at 3 on the number line and you move to the left 6 places, because we're subtracting 6, and we're getting less, than 3, or I think hopefully that made sense. We're getting smaller than 3, we're moving to the left. We're going to end up at negative 3. Negative 3 minus 6. If we're at negative 3 and we subtract 6, and we get even more negative 6 by 6, we're going to end up at negative 9. Okay, now the new thing. How do we subtract a negative number? Well, something I want to emphasize big time is that subtracting a negative is exactly the same as just adding it. This is probably not even the first time you've heard this, by the way, any of this. You probably did this in junior high or whatever. But subtracting a negative is the same as adding. So 3 minus a negative 6, that's exactly the same as 3 plus 6. In fact, I always make it a case to rewrite it. And that, of course, is just going to be 9. Likewise, in number 4, I choose to think of this as just negative 3 plus 6. And now you can think of the number line. Negative 3, it's in the negative. We're adding 6, and we're heading to the right 6 places. That's going to get us to 3. Negative 3 plus 6 is a 3. More examples. 9 minus 1 would be 8, right? Negative 9 minus 1, so we're at negative 9, and we're minusing 1. We're going to the left on the number line. We're subtracting and getting even smaller by 1. That's going to get us to negative 10. And again, just to emphasize it again, minusing a negative 1 is the same as adding 1. So this would, in this example, would just be that. And what would this be? Negative 9 plus 1. We're at negative 9, and we're going to the right 1 place. That's going to get us to negative 8. All right. Changing gears. We're now going to be doing multiplying and dividing with negatives. So you've been multiplying and dividing since about like 2nd grade or something, and learning your times tables, right? 2 times 3 is 6. 2 times 4 is 8, and maybe you listen to some records, or I don't know. But it was memorization of times tables, which again, even though you have a calculator always handy, it does help to know your times tables. It just does. And when you involve negatives, again, your calculator is always there, but it does help you. It is an advantage to know this by heart and understand how multiplying and dividing works when you start involving negative numbers, okay? So, I'm just going to double check that this is with multiplying, right? You can think of this as multiplying, like a multiplying symbol. That's fine, but this is going to hold true for both multiplying and dividing. So when you have a positive number times another positive number, what are you going to get? Is your answer going to be positive or negative? Well, positive, of course, okay? You've known that since basically second grade. Positive 3 times positive 9 gets you positive 27. You know, you just never actually pointed out that it was all positive. But anyway, this is going to be the same as dividing. So a positive divided by a positive will yield a positive answer. So all these answers we're going to write down doesn't just apply to multiplying, it's also the same as dividing. All right? So what do you get when you do a negative number times or divided by another negative number? Turns out you get a positive answer. And when you have a positive number and you multiply or divide by a negative number, you get something negative. The final answer is going to be negative. And if it's a negative times a positive or a negative divided by a positive, you get a negative. So one way you can like summarize this is that when you're multiplying and dividing two numbers and the signs match, your final answer is positive. And if the signs are different, your final answer is negative. Okay? Now, all these other examples, I hope you can be able to do in your head or do these in your head. But, you know, there's always a calculator. But 5 times 3, that's a positive times a positive. That's going to be positive 15. And if you have a negative 5 times a positive 3, those signs do not match, and you end up with negative 15. Positive 5 times a negative 3, that's going to be a negative. The signs do not match. Sorry for the hesitation there. It occurred to me that there's a lot of different ways to denote multiplication, right? You know, the old X thing doesn't really remain with us since grade school. You know, like we don't really use that multiplication symbol anymore. We use the dot symbol, or we just don't even have a symbol at all here. We just do 5 and the negative 3 like this. Like, you don't need to write this down, but if I showed you that, like, you should know that means multiplication. So please be aware of all the different ways to denote that two numbers are being multiplied. The dot, just having two things next to each other, like, you know, we're going to be getting into things like 2x, right? And you need to realize that this means 2 times x. Okay? Anyway. So negative 5 times negative 3, it's a negative times a negative. The signs match. And so the final answer is going to be positive 15 here. All right. I don't know if I'll remember to do this actually in class, but dividing, I want to point something out with dividing. And it's kind of like what I just pointed out with the multiplication and the symbols and the notation and stuff. Dividing, like if I wanted to, I don't know, let me just think of something off the top of my head. 10 divided by 2, right? Which is 5, but that's not the point. What I want to talk about is there any other way to write this as a division problem? Do I have to use that symbol, that division symbol, that looks like a UFO or something? But anyway, or a fraction, if you remember. But this symbol sort of looks like a fraction, doesn't it? But anyway, hint, hint. Is there any other way to write this as a division problem without using this exact symbol? There is. And speaking of fractions, this says 10 divided by 2. So from here on out, if you didn't already know this, I bet you did. No offense if you didn't. But from here on out, you need to realize all the time that a fraction just means division. So 10 over 2 just means 10 divided by 2. And now we will stop.